Okay, so in this problem, we know that 1 out of 4,000 people have a disease. So let's say this is 4,000 people. Obviously, it's not in my picture, and this is 1. And they have a disease, and we know that that disease is recessive. So if we were to say what their genotype is, this person is recessive, right? All these other people, what are they? Well, they could be big A, or they could be big A, little a. So we really don't know. But what is the, so first we have to ask ourselves, what have we been given? So in this case, we've been given a phenotype. We've been given the Q squared people and the P squared and 2PQ people, right? We've given a phenotype, and it's asking if it's in Hardy-Weinberg equilibrium, what percentage of the population is a carrier? So it's asking us for these guys who are carriers, right? We want to know these guys. So it seems like it's a sort of a complicated math problem, but it's not actually. Okay, so first we need to say, all right, can we solve for this right here? And the answer is no, not without some really complicated math. But this one seems pretty easy to solve. Q squared, okay, so Q squared is 1 out of 4,000. Right? So to solve that, all we have to do is take a square root. Okay, so we'd say 1 out of 4,000, and we'd take a square root of that. And that gives us, so taking the square root, that gives us 0.016, all right? And so if that is Q, then can we figure out what P is? Because we need P and Q to do 2PQ. So sure, then we just have to subtract it from 1 to get P. So that means that P equals 0.98. So we'll just round this to 0.02. Okay, so then to figure out carriers, 2PQ, we simply have to do the math. 0.02 times 0.98 times 2. And we get approximately 0.04. So that means 4% of the population is actually a carrier if it's in Hardy-Weinberg equilibrium. Okay, so let's look at this next one. We have to decide what we've been given and what we need to solve for. So in this one it says that brown hair is dominant to white hair, and 7 of the 12 rats have brown hair. Well, when I put it in picture form, if 7 out of 12 have brown hair, then how many have white hair? Well, the other 5, right? 5 out of 12 have white hair. So now we have to decide who those people are. What have we been given? Well, we've been given a phenotype. These 7 out of 12 are dominant, so they represent both our P squared and our 2PQ folks, right? Because they're both going to show that dominant color. And these guys are our Q squared people, or rats in this case. And it's asking us, what's the brown hair allele frequency in the population? So now we're saying, okay, it's asking us for an allele frequency. An allele frequency is P or Q, and in this case it wants to know the brown, so P. So you might say, all right, well, let's just solve the problem with the P in it. Can we solve this? Well, that's really complicated because you got these guys in there too. But again, we can solve this one. So if we just take a square root of 5 out of 12, we get about 0.65. So that's the square root of 5 out of 12. So that gives us Q, right? And then all we have to do is find P, and that's easy enough because we know that P and Q together equal 1. So if Q is 0.35, then P, or 65, then P has to be 0.35. Okay, and then the next question asks approximately what percentage of rats would be homozygous dominant. So now they're asking you, how many are P squared, right? These guys. Okay, so all we have to do is take 0.35 and square it. So that gives us P squared equals about 0.12. So about 12% are homozygous dominant, and then the rest of them would be heterozygous.